Topic today is on quadratic function. So how does a quadratic function look like? It's like this. Y equals to ax squared plus bx plus c. Now this is how our quadratic function will look like. Now what are those characteristics of quadratic function? One, a quadratic function has to have the highest power of 2, meaning our highest power for x is 2, is at degree 2. Then 2, it has to have a parabola shape. Its shape has to be a parabola shape. Then 3, it has a minimum point or a maximum point. Then 4, it has to cut the two axes of x, of the x point. Now let's solve a question on quadratic equation. Now the question is copy and complete the value for the relationship y equals to 3x squared minus 5x minus 7. Now the first thing is that we have to complete this table. Now how are we going to? Now I'm going to teach you two methods in completing the table. I'm going to teach you two methods in completing. Now the first method, method 1. Now the question is y equals to 3x squared minus 5x minus 7. Now, when x is 3, my y is equal to 35. Now, the next one is when x is 2, what is the value for y? So you write it. When x is equal to minus 2, so y. So it means that anywhere you're going to see the value for x, you put 2. 3 minus 2 raised to power 2 minus 5x minus 7. So now, I'll be having now minus 2 raised to power 2, that's 4 times 4. You put that in brackets, minus 5, So I'll be having minus 5 times minus 2, that's plus 10 minus 7. So this is 12 plus 10 minus 7, that's 3, that's 15. So my y is equal to 15 when my x is minus 2. So now the next one, when x is equal to minus 1, what is the value for y? So y, that means anywhere you see your x, you substitute the value for y. I'll be having 3 minus 1 raised to power 2 minus 5 minus 1 minus 7. So I'll be having minus 1 raised to power 2, that's plus 1, that's times 3, that's 3. Minus 1 times minus 5, that's plus 5 minus 7. So 3 plus 5, that's 8. 8 minus 7, that's 1. Now the next one, when my x is 2, 2 raised to power 2 minus 5, 2 minus 7. So 2 raised to power 4, 2 raised to power 2, that's 4, times 3, that's 12. Minus 5 times 2, that's minus 10, minus 7. So I'll be having 12 minus 10, that's 2. 2 minus 5, that's minus 5. Now when x is equals to 4, I'll be having y equals to 3, 4 raised to power 2 minus 5, 4 minus 7. So now 4 raised to power 2, that's 16 times 16 minus 20 minus 7. So 3 times 16, I'll be having 48 minus 20 minus 7. So 48 minus 20, that's 28. 28 minus 7, that's 21. So here is 21. Now this is method 1, how to get to complete your table. Now let's use another method to get our table. Now method 2. Now I believe that this method 2 is the simplest method for those that you, without calculator, you can use it, you can easily solve using this method 2. So now let's solve it. Now this is our y. Now for value for y, I have, this is our x, our x minus 3 minus 2 minus 1 0 1 2 3 and 4. Now I'll be having 3x squared minus 5 minus 7, then y. Now, I'll explain again. Now, this is the value for x given. X minus 3 minus 2 minus 1, 0, 1, 2, 3, 4. Because it is written that minus 3 is less than x and x is less than or equal to minus 4. Or equals to 4, sorry. So now the first thing is 3x squared. You're going to write out the question, 3x squared. This is 3x squared. Now the sign at the front, minus 5. This is minus 5x. Minus 5x. Now the next one, minus 7. Minus 7. This is our constant. Then our value for y. So now, when x is minus 3 raised to power 2, so that means that, it actually means that 3x raised to power 2, it means that 3 bracket minus 3 raised to power 2. So this means that 3, now minus 3 raised to power 2, that's 9. Now 3 times 9, that's 27. So here is 27. So now the next one, you put it again, when x is minus 2, so that's 4. 3 times 4, that's 12. So the next one, when x is minus 1, so 1 raised to power 2, that's 1, times 3, that's 3. So the next one, when x is 0, 0 times 3, that's 0. The next one, when x is 1, 1 times 3, that's 3. When x is 2, 2 raised to power 2, that's 4, 4 times 3, that's 12. When x is 3, 3 raised to power 2, that's 9, 9 times 3, that's 27. So now when x is 4, that's 3 x raised to power 2, that's 16, 16 times 3, that's 48. Now similarly, we're going to use the same method to solve this too. Now when x is minus 3, I'll be having minus 5x. Now you have to be very, very careful here. Normally there's minus sign here. So I'll be having minus 5 minus 3. That's plus 15. I'll be having 15. Now when x is minus 2, I'll be having 10. When x is minus 1, I'll be having 5. When x is 0, 5 times minus 5, that's 0. Now look at this too. Remember, I'm having minus 5x. That's the question. Now when x is 1, so I'll be having minus 5 times 1, which is minus 5. So here is minus 5. So when x is 2, I'll be having minus 5 times 2, that's minus 10. So when x is 3, minus 5 times 3, that's minus 15. When x is 4, minus 5 times 4, that's minus 20. Now, whenever you see constant, look at this constant. It's just minus 7, no x there. So you just write it there. Minus 7, minus 7, minus 7, minus 7. So now, let's calculate. So you have to be very, very careful when you want to do the calculation for this. Now, this means, I'll start with this. 27 plus 15 plus minus 7. So 27 plus 15. So that's 27 plus 15. That's 42 minus 7. That's 35. Have you seen it? We still end up getting the same thing. So the next one, 12 plus 10 minus 7. 12 plus 10, that's 22. 22 minus 7, that's 15. So the next one, when 3 plus 5 minus 7. 3 plus 5, that's 8. 8 minus 7, that's 1. So now we're having 0, 0, minus 7. So that's still minus 7. 3 plus minus 5 plus minus 7. So that's 3 plus times minus, that's minus, plus times minus, that's minus. So 3 minus 5, that's minus 2. Minus 2 minus 7, that's minus 9. So the next one, I'll be having 12 plus minus 10 plus minus 7. So I'll be having 12 plus times minus, that's minus, minus. So 12 minus 10, that's 2. 2 minus 7, that's minus 5. So 27 plus minus 15 plus minus 7. So I'll be having 2 plus minus 15, that's minus 15 minus 7. So 27 minus 15, So that's 12 minus 7, that's 5. 48 plus minus 20 plus minus 7, I'll be having 48 minus 20 minus 7. So 48 minus 20, that's 28 minus 7, 21. So have you seen it? We are still going to have the same it's the same numbers. So either you use method 1 or method 2, you still get the same answer. So anyone that is actually convenient for you, you're going to use. So now let's solve the main question. So using a scale of 2 centimeter to 1 unit on the x-axis and 2 centimeter to 5 units on the y-axis, draw the graph of y equals to 3x squared minus 5x minus 7 for minus 3 is less than x and x is less than 4. So you have to write that on your scale, which I've written it, 2 centimeter to 5 units and 2 centimeter to 1 unit. So now, before you start plotting any graph, you have to check what is the highest value for y. The highest value for y is 35 and the highest value for x is 4. So let's work with that. So I'll be having so this is my y-axis for positive and this is my y-axis for negative. Now this is my x-axis for positive and this is my x-axis for negative. So now for x, let's start with x. X is 2 centimeter to 1 unit. So meaning that each centimeter is 1 unit. So let's start with the negative aspect. Now this is 0. I'll be having minus 1, minus 2, minus 3, minus 4. So now for positive, I'll be having the highest value to is 4. 1, 2, 3, and 4. So now that's for x-axis. So now let's go for y-axis. Let's go for the positive. Now the y-axis is 2 centimeter for 5 units. So means that from here to here, that's 2 centimeter, that's 5, 10, 15, 20, 25, 30, 35, 40. So now let's go again. Similarly to for the negative, minus 5, minus 10. So this is it now. So the first one says that when x is minus 3, y is 35. When x is minus 3, y is 35. This is it. When x is 3, if you can't see it, you can work with your ruler. When x is 3, this is 3, y is 35. And this is 35. So now the next one, when x is minus 2, when x is minus 2, y is 15. When x is minus 2, y is 15. The next one, when x is 0, y is 1. No, sorry. When x is minus 1, y is 1. When x is minus 1, y is 1. So now you have to be very, very, very careful here. Now, from here to here is 5. So how are we going to get our 1? So this is it. It means that I'm going to count 2 to give me 1. At all the small box, I'm going to count 2. 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 2, 4, 1, 2, 5. So have you seen it? So 2 box is for 1, then 4 box, that's 2, like that. So you count it to get to 5. So now how am I going to get to my 1? I said from y is minus 1 to 1. So you place it, y is minus 1. So I'm going to count 2 box for 1, 1, 2. So that means that my 1 is here. So now the next one, when x is 0, my y is minus 7. When x is 0, my y is minus 7. Now look at it, my y for negative. So when x is 0, 0 is here on the region here. My y is minus 7. So this is minus 5. So remember, we are going to count 2 box for 1. So minus 5, 1, 2, that's 6. 1, 2, that's 7. So it's here. So the next one, when x is 1, my y is minus 9. When x is 1, my y is minus 9. So 1, this is 1. This is 5, 6, 7, 8, 9. So it's going to be here. So now the next one, when x is 2, my y is minus 5. When x is 2, my y is minus 5. So it's here. When x is 3, my y is 5. When x is 3, my y is plus 5. When x is 4, my y is 21. Now look at it. This is 5, 15, 25, 15. Sorry, 5, 10, 15, 20. So now for 21, remember we're counting 2 box. 1, 2, so that's 21. So now let's join our point. You can join your point using your French curve, but I'm not with my French curve right now, so I want to use my hand. You have to be very, very careful. So this is it. So now you can see that it has a parabola shape. It is parabola. So now let's check it. So the next question, C, we've actually plot our graph. The next question says, now from the graph, find the root of the equation. Remember, the first characteristic of quadratic equation, it must have a 2 root, a 2 root of x. So now let's find our root. The root actually means where it actually cut from the point. So let's see, it's here and here. It actually cut it from here and here. So let's count from 0, 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9. So here is minus 0.9. So for the other point, where it actually touches it, so we're having 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. So here is 2.6. So the root of the equation is 0.9 and 2.6. and 2.6. So now the next question says that estimate the minimum value of y. So let's get our minimum value for y. So this is our minimum. Now, how do you get your minimum value? I told you part of the characteristics is that you have minimum value or maximum value. Now, for minimum value, it will be negative. For maximum value, it will be your y will be positive. So now looking at it, my minimum value it's like a parabola shape. For maximum value, it's going to be n. It's going to have an n shape. So now for minimum value, so now look at it. How will I get my minimum value? I'm going to use a broken line for that. So this is it. So now this is our minimum value. So now let's count. Each two box is sorry, one box is 0.5 and two box is 1. So let's use the two box. Minus 5, 6, 7, 8, 9. So it crosses at minus 9. So that means that my maximum, let me write it for my figure 1, the roots of the equation are x is minus 0.9 and x is equals to 2.6. That's for Roman figure 1. Now for Roman figure 2, the minimum point, the minimum value of y is minus 9. Now Roman figure 3, calculate the gradient of the curve at x equals to 2. Now the gradient of the curve at x equals to 2. So now this is the x equals to 2 and this is where it actually touches. So now you're going to place your ruler on your graph. So this is it. So at x, so now for us to get the gradient, we're going to form a triangle. Remember the shape, the gradient, the gradient might be small or big, but I prefer my gradient to be very big. So now let's get the gradient. So let's take our measurement. Now, if you're actually measuring your slope of your gradient for a graph, you're going to make use of you're going to make use of your centimeter part of your ruler. Now this is it. So I'm going to place it here. Now from here to here. So let's first of all let's label it. Let's make this A, B, and let's make this C. Now to get our gradient, it is BC over BA. Now change in Y over change in X. So the gradient is equal to BC over BA. So let's take our measurement from BC. This 40, 41, 42, 43, 44. So BC is 44 centimeter over. So BA This is 20, 25. That's 25.5. So let's get the gradient. Now 44 divided by 25.5, you're going to have 1.75, 1.72549, approximately 1.73. So the gradient at x equals to 2 is 1.73. So thank you.